this example asks you to find the range of each question. So remember, like, the range is the potential y values of each function. I'm actually going to use Desmos to help us to do that a little bit, because I think it's easier to see it with the graph. But we're also going to talk about, the transformations, because that's really what helps us to get there, okay? So this first problem says the square root of x minus 5 plus 9. So let's take a look at that on Desmos. So there's a square root, so of x minus 5 plus 9. So there's our graph. Okay, I guess it is centered. There we go. So I'm having a hard time because it's really hard for me to see the axes here. So I'm just going to make sure that oops, I should put y equals 0 on there. I'm just going to make sure it's nice and I don't even know what that is. If you have my kids, they will tell you how much I love technology. There we go. That's a little easier to see. This one's like way up here, and it's hard to see these axes sometimes on Desmos. So what I did was I put the axes in black so that they would really just like pop for us to see. So here's the square root function. Notice this endpoint here, which won't stay highlighted, thanks for that, Desmos. The x minus 5 tells us that this endpoint was translated to the right by 5 and up by 9. So when we're talking about the range, we're talking about the potential outputs that can come from this function. Well, the lowest that this function goes is this endpoint right here. It doesn't go any lower than that. So this is the minimum value, and then the graph goes on for forever upwards. So the range for this would be all the y values greater than or equal to 9. So when I go back to our little slideshow here, I'm going to say y is greater than or equal to 9. Alright? Now it is worth noting, it's pretty much always going to be greater than or equal to 9 unless you have a negative number in front of the radical. Because if there's a negative, it flips it upside down, and that makes it go down for forever. Alright, so you want to look for that negative versus not negative to determine the direction. Alright, so this next one says x plus 12 and a minus 8. So I'm just going to adjust that. Hunt it down on our graph paper. There we go. So if I'm thinking about it in terms of transformation, this plus 12 is translating to the left by 12. And the minus 8 translates it down by 8. Now, because this was not reflected, it goes up for forever. It has kind of a slow incline, but it's still going up for forever in terms of end behavior. So the range to this is all the y values that are bigger than or equal to that negative 8. So that's what we're going to say here. Now it is worth noting the range always talks about y. If we're talking about x, we're talking about domains, y'all. So our next one talks about x plus 1 and then a minus 13. So thinking about transformations, this was translated left by 1 and down by 13. And so you could see that the lowest point on this graph is down at negative 13, and then it continues up for forever. So I would say that y is greater than or equal to negative 13. Alright, wow, we put a lot of examples of this on the slideshow. That's alright, good practice. Alright, so we have x minus 4 and then a plus 3. So the minus 4 is describing translating to the right by 4, and the plus 3 shows up by 3. So the lowest point on my graph here for the range is here at 3, and then it continues to go up for forever. So I would say that y is greater than or equal to 3. Do y'all see the trend here? Whatever that k value is tends to be the expression for the inequality. You just have to be careful that you're talking about y's for the range and that you recognize if there's a reflection or not. So the next one talks about x minus 2 and then a minus 1. So the -2 translates the graph 2 units to the right, and the -1 moves it 1 unit down. However, the graph is still increasing. So the lowest value is at -1, and then all the y values above -1, or equal to the -1, are also included in the range. Then our last one, I'm gonna pop it into Desmos because I've done it every single time. But the +6 that's on there is describing going to the left by 6. And then the 10 tells you that it went up by 10. So you can see it way over here. If I could click on it, there we go. So the minimum value here is 10, and then the graph continues to increase. So I would say that y is greater than or equal to 10. Not too bad if you remember your transformations.